Alrighty, hi kids. What we're going to do today in this video is we are going to go over topic 9.3, modeling ratios. You'll need to open up your book to pages 238, 239 to follow along. Do that now. Alrighty. When we talk about modeling ratios, basically what we are doing is we are talking about proportions. So this lesson is about creating proportions, okay? Or creating proportional amounts. So remember, there are two ways of creating proportional amounts, okay? We could have a ratio which is 4 to 12. And if we wanted to create proportions, we could certainly multiply by a common factor such as 3, and we would create proportional amounts. 4 times 3 is 12, 12 times 3 is 36. Okay, so this 12 to 36 ratio is proportional to this 4 to 12. Okay, and again, if we can use multiplication, we can also use division. So we could take the ratio of 4/12, a 4 to 12 ratio, and we could divide it by the greatest common factor of 4, in which case you would get a ratio of 1 to 3, which is a 1 to 3 ratio is proportional to a 4 to 12 ratio in this situation. So that's essentially what we're going to do. We're going to show this process using models, all right? So anyways, let's take a look at what the book says to it, give the situation the book gives us, okay? And it asks, how can you diagram to help you solve a ratio problem? And then they give us a model problem. The ratio of footballs to soccer balls at a sporting goods store is 5 to 3. If the store has 100 footballs in stock, how many soccer balls does the store have in stock? So in other words, out on display, they have 1, 2, 3, 4, 5 footballs and 3 soccer balls. In the stock room, they have more soccer balls and footballs. Okay, and the ratio out on the floor, okay, which is a 5 to 3 ratio, okay, is proportional to the number of balls they have in the supply room. All right, so when setting this up, the first thing I tell kids is when you see a problem like this, make your initial ratio right off the bat and label it. So I would just kind of like label that F for football and this for soccer ball, okay? And then look at what they want you to compare first to figure out what the proportional amounts will be. And in this case, they're comparing footballs to footballs first because they give you the football numbers. So then you could simply take the number of footballs in the back in the storeroom and you could write it as that part of the ratio. So in other words, now you're comparing footballs to footballs. What they're wondering is how many soccer balls are in the back room? If these amounts are proportional, how many soccer balls would there be? Now, many of you have probably figured out the answer already, but the book does a really nice job of showing you a model for representing this. Okay? Now remember, here's our question. If the store has 100 footballs in stock, how many soccer balls does the store have in stock? Okay? Well, in this case, you could model the relationship. The ratio of the number of footballs to the number of soccer balls is 5 to 3. Okay? And so here they have footballs, and here they have soccer balls. And basically what they've done is you have one rectangle for each of the footballs. Okay? One rectangle for each of the footballs. And then you have one rectangle of the same size for each of the soccer balls. So essentially you have 5 to 3. Okay? Now, our goal, of course, is to find out if they have 100 footballs, how many soccer balls do they have? Well, you can use the same diagram and equivalent ratios to find the number of soccer balls the store has in stock. So in other words, you take these diagrams over here, and remember, our goal is to get 100 footballs. And this is going to be, this 5 would be proportional to 100. So right away, you could think to yourself, okay, 100 divided by 5 is 20. So I'm going to put 20 in each of these rectangles, okay? And they will add up to 100. Well, if I put 20 in those rectangles, I'll need to put 20 in these rectangles as well. And then once I add those up, it will tell me how many soccer balls are in stock. And of course, this is just a matter of doing 3 times 20, which equals 60. So when you look at this, we have 5 footballs, and we have an equivalent amount of the 100 footballs, or we have used multiplication by 20 to get up there, and 3 soccer balls times 20 gives us 60. So that tells us there are 60 soccer balls in the sporting store in the stock room. Okay? So what you've done essentially is this. You've taken your 5 to 3 ratio. Whoa, that was bizarre. You've taken your 5 to 3 ratio, and you've made a proportional amount through multiplication of a common factor. Okay? And so that's essentially what you've done, but you've modeled it. All right? Now, the book also gives us another example of a model, and this is called a double number line diagram. Okay? That can be used to solve problems involving ratios. Again, here's our problem. Okay? And like I like to do is when I read these problems, I like to look for the initial ratio, the initial comparison of amounts. Kate can run 2 miles in 23 minutes. At this rate, how long will it take her to run 10 miles? So our question is, how long will it take her to run 10 miles if she can run 2 miles in 23 minutes? Well, our initial ratio in this case is going to be a 2 to 23 ratio. So I have my miles, and I like to write my miles down and then say that I have 2 miles. Then I have 23 minutes, so I'm going to label that minutes, and I have 23. Okay? So this is my initial ratio. At this rate, how long will it take her to run 10 miles? Well, now I can just compare. I can take, okay, well, I'm going to create a proportion, and I know that I have 10 miles, so it's miles to miles. All right. Now, mathematically, you could simply say to yourself, okay, 2 times 5 equals 10. Well, if I want to create a proportional amount, I have to multiply 23 by 5. 5 times 23 is 115. Okay? So our proportion would be a 10 to 115. Okay? So this tells you how long it would take her to run 10 miles. It would take her 115 minutes. But if you use a double number line graph, look at how you can set it up. Okay? What you have here is you have your distance, which is miles, 2 miles, and your time, which is 23. This is your initial comparison, okay, or your rate. Now, what we want to do is get to 10. And so when you get to 10, what you're going to do is you're simply going to, you want to reach 10, so you're going to basically skip count because 10 is a multiple of 2. Okay, so you're simply going to do 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 2 is 10. All right? So using that same strategy of just adding, or that same pattern of just adding, 23 plus 23 is 46. So there's an equivalent ratio. All right? So we can see that we're on track with our pattern. So 23 plus 23 is 46. 46 plus 23 is 69. 69 plus 23 is 92. 92 plus 23 is 115 minutes. And so you can see where you've created these number lines and you've essentially modeled a proportional amount. So if you have a rate of 2 miles per 23 minutes, 10 miles will take you 115 minutes. So you can use a diagram, or you can do it like we learned yesterday. All right? There's 2 ways of answering and solving this problem. And as they said, you count by 2s along the line for distance until you get to 10 miles. Count by 23s along the line for time using the same size spaces, and that will be your model. And your answer, of course, it will take Kate 115 minutes to run 10 miles. Okay? So anyways, that's how you would do these problems. And what I want to do right now is I'm going to have you look at problem number 1 in your book, and on a piece of paper, see if you can set up a model like this to solve this problem. So go ahead and pause the video, and then I'll go over the answer with you and how we could achieve it. Alrighty, let's see how you did. Ty is making some trail mix based on a recipe that combines 2 cups of nuts with 3 cups of granola. If Ty has 6 cups of nuts, how many cups of granola should he use? Classic problem, recipe problem. I want to increase the size of my snack, so I've got to proportionally increase the ingredients. All right, so here's our situation. Ty is making some trail mix based on a recipe that combines 2 cups of nuts. So I'm going to write down the cups, and I have 2 of them, okay? To the number of cups of granola. So I'm going to just write gran for granola, and I have to have 3 cups that the recipe requires for. Okay, so it requires 2 cups of nuts and 3 cups of granola. He has 6 cups of nuts. How many cups of granola should he use? Well, we're going to do cups to cups again, okay, and that's 6. So the unknown is how much granola he's going to need, okay? If he's going to use all of those nuts, then how much granola will he need, should he use, okay? So in this case, mathematically, we know that you can go from 2 to 6 by multiplying by 3. So if you multiply this term of the ratio by a factor of 3, you have to multiply this term of the ratio by a factor of 3. 3 times 3 is 9. So you would need 9 cups of granola to make it happen. Okay? Now, if you made a diagram to show this, you would model it and you'd say, okay, this up here represents my nuts, and this represents the granola. Okay? Now, remember, we want to go from 2 to 6. Okay? And so when we do that, each one of these, if I'm going to take these 2, I have to give them a value that will equal 6. So in this case, it will be 3. So I have 2 sets of 3 to equal 6. Well, if I'm going to apply a value of 3 here, I have to apply a value of 3 down there as well. And so when we add 3 plus 3, or multiply 3 times 3, you get a ratio of 6 to 9, which is also tells you how many cups of granola you're going to need. Okay? All right, let's look at this problem that Angela has, okay? Angela, see if you pause the video and see if you can solve this problem. and then we'll go over it. Okay, Angela is helping her father paint a fence. She can paint 3 sections of the fence in 25 minutes. How many minutes will it take Angela to paint 12 sections of this fence? Well, they want us to use a double number line to model the equivalent ratios. So let's take a look at our first ratio, our first initial ratio, okay? And so it tells us that she can paint 3 sections of fence in 25 minutes. So it is a fence to minutes comparison, okay? And 3 sections of fence in 25 minutes, okay? So that's our initial ratio. So when we set up our double number line, like so, our initial ratio will be 3 to 25, okay? How many minutes will it take Angela to paint 12 sections of this fence, okay? So we will, if she can paint 3 sections in 25 minutes, how long will it take her to paint 12? So we want to go from 3 to 12. So in this case, we could say, all right, well, if I do 3 plus 3, I get 6. 6 plus 3 equals 9. And that's a pretty big jump. I could have made my number line a lot smaller. 9 plus 3 equals 12. So I've increased each of these by 3 each time. Well, if I do that down here, I'm going to have to make this 50, and then 50 plus 25 is 75. 75 plus 25 is 100. So 12 sections of fence should take 100 minutes to actually paint. Okay, and that's how you'd make a double line model for ratios. Again, if you wanted to just do this mathematically or algorithmically, you could simply take your sections, which are 3, your minutes, which is 25, and then say, okay, we're going to, how many minutes will it take Angela to paint 12 sections? Okay, take and create my other ratio over there. I have the one term. We know that 12 is a multiple of 3, so 3 times 4 equals 12. And I can just multiply 5 times 4 to get 100 minutes. Okay, so there's your answer, doing it mathematically. So you can create equivalent ratios that are proportional using what we learned yesterday mathematically, or by using models such as the double number line model. Okay, if you have any questions about this skill and what it is you need to do, feel free to review the Pearson video, look in your book, or see me or your parents for help.